Hello, in this video we will see the response of driven RL circuit. So far we have considered forcing function equal to 0, but in this we will consider a DC voltage source and what is the response of the circuit. Okay, so here we will consider this circuit where t equal to 0 switch will be closed, and before it was open for long period of time. So that means I initial current through inductor is 0. At t equal to 0 switch will be closed. Okay, and if we write that for t less than 0, I of t is 0. Now we will consider for t greater than 0. If you write the KVL in this, switch will be closed. KVL, if you write, it is IR plus current through inductor, voltage across inductor is L di by dt equal to V0, and if you divide by L, it will be di by dt plus R by L I equal to V0 by L. Now if you substitute, let P equal to R by L and Q equal to V0 by L, where Q is a forcing function but it is divided by L. Okay, so then this equation becomes, equation 1 becomes di by dt plus pi into Q. Okay, so we will call this one as equation 2. Now you multiply both sides by e power pt. So this will be di by dt into e power pt plus e power pt pi into e power pt q. Okay, so this we will call equation 3. Now if we consider derivative of product, if you consider, that is d of xy is nothing but x dy plus y dx. So in this, if we consider let x equal to I and y equal to e power pt. So this will be d by dt of I into e power pt will be, if you apply this derivative of product rule, then this will be I, that is x into dy. Dy is differentiation of e power pt, that is p into e power pt plus y is e power pt into x, that is di by dt. So in equation 3, if you compare this left hand side is nothing but d by dt of I into e power pt. So instead of writing this thing, I can write like this: d by dt of I into e power pt. I can directly write like this is equal to q into e power pt. Okay, now if we integrate on both sides, So what we will get, if integrating on both sides, we will get I e power pt equal to q e power pt dt and integration constant a. Integration constant a. So then if you multiply both sides by e power minus pt, so equation will be I equal to e power minus pt q e power pt dt plus a into e power minus pt pt. So this is the equation, this is the response of driven RL circuit, the expression for current in a driven RL circuit. Now this has two parts actually. This one we will call part A and this one we will call part B. Okay, so it has two parts and we will see the significance of each part. So first one we will consider part A. So part A, if you see what is part A, part A is A into e power minus pt. So if you compare this one with the source free RL network, you will see the similarity. So we can write this can be compared to the response of RL network with forcing function equal to 0. So then that's why it is called natural response. This part of the solution matches with the source free RL network. Okay, so what happens here, in this driven RL circuit, one part of the solution will be the natural response, where if you substitute to infinity, this natural response will die out. So in a driven RL circuit, we can see one part that belongs to natural response of the circuit. Natural response means without any forcing function, what is the response? That is A into e power s1t. The same response we are getting here also. Okay, where but one thing you have to see, the A in the previous case force free RL circuit, A is nothing but I of 0, but here this will be initial current of complete circuit. We will see that, we will discuss that later, how to find this A, we will discuss that later. Okay, so that is about the part A. Next one is part B. What is part B? So part B, it represents, what is part B? Let us write the part B first. Part B is e power minus pt integration q e power pt dt. This is a part B. So we can write it represents the steady state response. Steady state response. Steady state response. It describes the forcing response or the response. It describes the response after natural response has died out. Natural response has disappeared. So this part B is something to do with the forcing function. You can see that we defined Q is nothing but a forcing function divided by L, it is V naught divided by L in this case. So part B is something to do with the forcing function. So this part B will tell when natural response has disappeared, what is the final or steady state response, that it will explain. So in this case here Q is a DC, isn't it? What is the Q actually? Q is V naught by L, but V naught is a DC value, L is a constant. So I can write here, I want to part B only, I have to let it be IF. IF is nothing but part B. So part B is e power minus pt integration e power pt dt. So if you integrate this one, Q is a DC value and divided by a constant, so that I can take outside Q outside P, and e power minus then integrate if you pt. So this is nothing but Q by P. So here also we will write this part In, we will give symbol for part A, that is In, that is nothing but A into e power minus pt. This is In, and IF is the forced response or steady state response, that is nothing but Q by P. So complete response, if you find complete response if you find, that is I equal to In plus IF, where In belongs to natural response, that is the inherent nature of the circuit. So that is nothing but A into e power minus pt, plus IF is the closed response, IF is the forced response, so that is Q by P. So this is the complete response. Here we have to find A here, the constant A we have to find. Okay, so let us find A. What is A? And already we know that we will substitute the other values, that is Q is nothing but V naught by L, that we already know, and P also we know, P is nothing but R by L. So your I of t, let me write in another page, I of t equal to A into e power minus, that is natural response, e power minus pt, A into e power minus pt, P we can substitute now directly, R by L t, plus Q is V naught by L and P is R by L. Okay. Now at t equal to 0, we already know that I of 0 is nothing but 0. So you see the start from the beginning where we started here. So in this you can see here at t equal to 0 the switch is closed. Before that switch was open for a longer period of time. So that means I of t, I of 0 is 0. So that we already know. That you have to substitute in this. This should be taken care. You have to substitute that I of 0 0 in the complete response, not only in the natural response, in the complete response. What do you mean by complete response? Complete response will have forced response also, natural response also. In that complete equation, you have to substitute I of 0, not simply in I of n. So that one care should be taken. Okay. So we'll solve, when we solve the problem, we'll understand that clearly. Okay. So I of 0. So that means 0, that is equal to A e power 0 plus V naught by R. So A is nothing but minus V naught by R. Now we can write the complete response. So I will write once again, complete response is I of n plus I of f, natural and forced response. Natural response is A into e power minus pt, forced response is Q by P, but all the values we have found now, we can substitute that, it is V naught by R e power minus R by L t plus Q by P is directly given, that is V naught by R. So together we can write V naught by R into 1 minus e power minus R by L t. So this is the complete response. So a driven RL circuit, if you see, if you apply a DC source, DC voltage source, the response will be V naught by R into 1 minus e power minus R by L t. Okay.